Welcome students. Today we will learn the analysis of beam subjected to sinking of support. Now this is a beam is subjected to a sinking of support. That support B is sink by 300 upon EI and support C is sink by 100 upon the EI. Now our first step is to calculate the degree of indeterminacy, that is DI is equal to 5, 1, 2, 3 here unknowns 4 and 5 minus available coefficients 3, so that is the 2. It means we have to remove the two unknown forces from this 5. So it is easy to remove the moments from the support. So here is a moment and here is a moment. So we are removing the moments. So remove a moment at A and the B. It means insert the hinge at A and insert the hinge at the B. So this is the deflected shape due to this load, and this is a deflected shape due to this load. Now this is the slope at A, at B. This is slope at B in AB span. This is the slope at B in the BC span. Now our basic equation is dq is equal to dql plus f into the q. These all are the matrix. This dq matrix, then dql matrix, f matrix and the dq matrix. We know this dql, it means the action developed at the coordinate. This is our remove the moment at A and remove moment at the B. So this becomes our dql1 at here, and at B is dql2. So action developed at A and B due to this external loading, that is called as a dql, and this dq is our important because the initial action, initial displacement, not action. This is the dq is the initial displacement at the coordinate, that is meant at 1 and at 2, and this dql is the action developed at 1 and 2 due to this external loading. Then f is the flexibility matrix and q is the our unknown forces, that is q is our now at A is the MA and at B is the MB. So this is our Q matrix. Now we develop here the dql matrix. What is here? The Ti is equal to 2 means we have removed here the two forces, that is the moment at A and moment at B. So dql is dql1 and dql2. Here. So dql1 that is, it means here we have to find out the slope due to this external loading at the 1. So that standard formula is WL cube divided by 24 EI. So that is W is 10 into L is 8 cube, and that is the 24 EI. So this final value is 213.33 divided by EI. Now at here we are assuming the like this. Here we are assuming this type of rotation 1, and here 2. Now due to this load, this rotation and this rotation is same, that is why this value is the positive. So now we have to find out this dql2. It means a displacement caused at 2 due to this external loading. So here dql2, that is the slope at B in AB span and slope at B in BC span. So due to these loadings, we have to find out the slope at B due to this loading also and due to this loading also. So now dql2, that is equal to, now here is 1 point load and this is our the UDL 10 kilonewton per meter, and this is 50, this is 4, this is 2, and this is 8 meter. So this is our hinge and we want a slope at here and here, this both the span. So for this we know again the slope is WL cube divided by 24 EI, and for this point load, let's have formula is W into B divided by 6 EIL in bracket L square minus B square. Now if you put here values, this value is the same, that is the 213.33 divided by EI, then here plus 50 into 2 into 6 square minus 2 square divided by 6 EI into 6. So this final becomes 302.21 divided by EI. Now these both values are the positive because now here this our rotation assumes like this is here at the coordinate 2, and what the slope produce at B due to this both loading, both having the same direction, that is why this both the values are the positive. Now our aim is to find the flexibility matrix, that is the F matrix. Now here di is equal to 2, it means we have developed the 2 by 2 matrix, that is the F11, then F21, F12 and F22 matrix. So now at here now for our sake of convenience we draw this as separately like this. Now this is our rotation 1. So this is our point 1. So use this as F1. Now we are applying. Now here is the so this will not produce any effect in this span BC. This will produce only the effect in the span this AB. This is 8 meter and this is 6 meter. This coordinate is 2. So this is called as F2. Now we are applying the rotation at 1. So apply here, write 1 here, write 1 here. So F11, that formula is the L of this AB upon 3EI. So L of AB is 8 by 3 EI, so that is equal to 2.67 EI. Then the effect at 2 due to the application of rotation at 1, that is F21, that also is equal to F12 is equal to. Now this will not produce, because due to hinge here, this will not produce the effect in this span BC, only in the AB span. The formula is the LAB divided by 6 EI. So this is 8 by 6 EI, so that becomes 1.33 EI. Now our aim is to find the, this is again we should draw separately here. This is 2, and this is 1. Now this is F2, this is F1. Now we are applying the unit rotation at 2, so 2 and 2. So F22 is applied the rotation at this span also, and in this span also, means in the span AB also and in the span BC also. So F22 becomes the LAB divided by 3 EI plus LBC divided by 3 EI. So here LAB is 8 by 3 EI plus this becomes 6 upon 3 EI. So this becomes is 2.67 and this is 2. So 4.67 divided by EI. So we got here this matrix, that is F matrix, that is 2.67, 1.33, 1.33 and 4.67. So initially we have already the here the this DQL and DQL2, DQL1. So now here you also write the DQ matrix, DQL matrix, that is DQL1 and DQL2. So DQL1 is 213.33 and that DQL2 is 302.21 upon A. So the formula is DQ is equal to DQL plus F into this Q. So we have the Q matrix, F matrix, DQL matrix. Now important is the DQ matrix. Now here in our problem that is a support sink at B and the C. So support, this is now here we know that delta A, that is sink at A, is 0. Then delta B, that is sink at is 300 divided by EI, and delta C, that is the 100 by EI. So now this is 300 by EI. So here is so the IB, so the IB and this is IB. So now this IB, that is what, this is 300 divided by EI. So IB is nothing but this IB value is delta by L, that is 300 divided by 80. This also I is the same, that is the 300 divided by 80, because the formula is what? Delta by L. Slope at here A and B is the same, I and IB, that is this delta divided by this length, that is this 8 meter. Now at here this IB, because this is 100 divided by EI, this is 300 by EI, so this becomes what? This becomes the 200. The formula is what? First, that delta by L here also. So his add to this delta minus this delta. So this becomes 300 minus 100 divided by EI. So this becomes 200 divided by EI. This is the delta. Now here, because delta at here is delta B minus delta C. Now the formula of this IB is 200 formula delta by L. So that is the 6 EI. So at this B is 300 upon 8 EI, IA is 300 upon 8 EI, and this IB, this becomes 200 upon this EI. Now due to this sinking here, the movements are produced like sinking moment in this fashion. In this way, and here also this is in this way. At B like this, and at A is like this. These are the sinking moment due to this sinking of this support B. At support B is in this fashion, and at A in this fashion. So now our aim is to find out the DQ. So at this is quadrant 1, which we have released here. So this becomes DQ1, and here we have released the moment also. So this becomes DQ2. So initial displacement at 1 and initial displacement at 2. So DQ1, that is the initial displacement, or that is what? It is a rotation or a slope at A. So that is equal to what? Is 300 divided by 8 EI. Now here our assumed direction is like this, and the produced rotation due to the sinking of support is in opposite direction. That is why this value is the minus. So this becomes what is 37.5 minus divided by EI. Then DQL2, that is what? Is a slope at B in AB span and slope at B in BC span. So slope at B in AB span and slope at B in BC span due to this sinking. So in this AB is what? Is 300 divided by 8 EI. Now this both rotation, what the due to this sinking are like this, and what our assumed rotation are also the same. That is why both value are the plus. So this is 300 upon EI here, and this is what is 200 divided by 6 AI. Assume direction, what the produced direction, both are the same. That is why this both value are the plus, and this final value is 70.83 divided by AI. So here we got the value of dq1 and the dq, no, this not here, dq2 only. This is dq2 only, not dql. Is dq1 and dq2 at here. This displacement caused due to this sinking of support. That is, we have removed the moment. That is why you have to find out the slope at 1 and at 2 due to this sinking of the supports. It is a dq1 and dq2. So we got here the matrix dq is equal to this dq1 and dq2. So this value is the minus 37.5 and plus 70.83 1 upon the EI. Now we got value dq, dql, f and q. Now put keeping all this value into this our equation. The formula is dq is equal to dql, these all are the matrix, plus f matrix, then q matrix. Now dq matrix is what? Minus 37.5 and 70.83 1 upon EI is equal to, now dql matrix is what? 213.33 and 302.21 1 upon EI, and plus this F matrix is 2.67, 1.33, 1.33, 1, which is 4.67 to 1 upon EI. This is unknown coordinate and unknown for, that is MA and MB. So now take to all this left. So this is what? MA, MB into this matrix, that is 2.67, 1.33, 1.33 and 4.67 1 upon EI is equal to this minus 37.5 and 70.83, and this value are the minus 213.33, 302.21. So what our final aim is to find the MA and MB. So that is equal to this, tick towards the right side inverse. So EI is 2.67, 1.33, 1.33 and 4.67 inverse. Now this both is having 1 upon EI, this both is having 1 upon EI. So this becomes the minus 250.83 and minus 231.38 1 upon EI. So here this EI gets cancelled. So now we got the value of this MA and MB, that is equal to minus 80.81 and minus 26.5. So now what is here? Minus indicates means what? We have assumed direction. Assume direction of this of rotation is like this. all are the sagging, but minus means the movement produced at A and at B are the hogging. So now we will draw the bend moment diagram here. So this is WL square by 8 and second one is the WAB by L. This is the 80 and this is 66.67. Now here we are initially assume the rotation is in sagging moment, sagging way, but our answer is negative. It means that produces in this way, and this is the hogging. So take here this word 80.81 here. Now here also initially we are assume in this fashion, that is the both are the sagging, but answer is negative. It means like this, both are the here hogging. That value is 26.5 and this is simply supported is 0. So join this, this value is positive, negative and negative. So this is the BMD.